Okay, so the first thing we talked about yesterday was this notation and how you rotate or rotate something without stretching it. Okay, so here's what the notation looked like. If I put a capital R and then as a subscript, I write 0.45. Okay, so when you see that, what that tells you to do, if you were going to do it to a point, so Z is some point, you know, it's a complex number. Like this one would be 1 plus 5i. Okay? Now, I want to take this and I want to rotate it 45 degrees. Oh, I'm sorry, positive 45 degrees. So I want to rotate this 45 degrees this direction. That's what that's telling me to do. Okay, if the 45 was negative, then you would rotate it this direction. So this would be negative 45. Okay, because remember, this right here is clockwise, and this angle is counterclockwise. So when it's positive, it's so you always got to remember this. Positive angle is counterclockwise. A negative angle is clockwise. Okay, that's how they move. All right, so this means rotate some point 45 degrees. All right, well, how do you do that? Well, you take the point, in this case, the point's called Z, and you go to 45 degrees right here, and you take the two coordinates, and you make a complex number out of them. So those coordinates are positive root 2 over 2 plus positive root 2 over 2i. And what this does, that is going to rotate Z 45 degrees counterclockwise. All right, so let's say we wanted to do this rotation. I want to rotate Z 60 degrees counterclockwise. So then I'm going to take the original point, and what would I multiply it by? So I go to 60 degrees, go to these 2 points, coordinates, and I make a complex number out of them. And that's how you would rotate Z 60 degrees counterclockwise. Okay? How would I rotate it 30 degrees counterclockwise? Well, go to 30, make a complex number out of those 2 coordinates. And what you're going to do is multiply that by whatever your point was. In this case, your original point is Z. So getting this part, guys, is really simple. Just go to the angle and use the coordinates. Okay, go to the angle and there's 30 and use the coordinates. Okay, so what would this one be? I want to rotate point Z negative 30 degrees. Say it again. Say it one more time. No, close. So here's negative 30. There's my coordinates. So this is the real part. This part would be positive, root 3 over 2. This part would be negative, 1/2 Z. You see how I got it now? All right. Okay, if I wanted to rotate negative 45 degrees, okay, Emily, how are we going to rotate? What would I multiply Z by to make this rotation happen? Yep, root 2 over 2 minus negative, or root 2 over 2 I. And that would rotate it negative 45 degrees. There it is. There's my coordinates. So what these do, they rotate things, but they don't stretch them. This is a rotation without a stretch, without a dilation. Okay, so that's what we talked about yesterday. Okay, now the other kind of notation that we looked at yesterday was flipping over a line. So if you had, let's say, a coordinate plane like this, and I had the point 1, 5I. So right there. All right. And I ask you to do this to it. R, lowercase r, real axis, Z. Okay, so what this means, guys, so I need everyone's eyes up front so you understand this notation because you're going to see it again today. This means take this point and flip it over the real axis. This is the real axis. So if you look over there on the sideboard, you notice where it says the conjugate flips it over the real axis. If I do the conjugate, I get 1 minus 5I. That flips it over the real axis. So the way that you accomplish this is by doing the conjugate. You press that conjugate button and it flips it over the real axis. All right. So what we're trying to do today is instead of flipping it over the real axis, we're trying to flip it over any line. Okay, so if you look at what we're doing here, we want to take this point Z and we want to come up with a transformation. So we want to get a formula that makes this happen. Okay, we want to find a formula that takes this point and reflects it over the line L. So we want to come up with what would this point, how would we get it to be here? Okay, so we want to find a transformation, so a formula that reflects over a line y equals x. Over the line y equals, or over the line L. That's what this means. So this notation that I'm highlighting in yellow, that's what that means. This. Okay? So it's this right here. C prime is the reflection of a complex number over the diagonal line L. Okay, now before we go any further, I'm going to get a piece of tracing paper here. Don't do this with yours yet, because we're going to use it for something else. But this is what I've done here. Let me put it up on the screen. Okay, what we're trying to do is this. We want to take this point. Okay, so I just traced it, and I put a little X where the origin is. Okay, what would be the equation that would make this happen? Ready? It's very exciting. 5, 4, 3, 2, 1. Amazing. Amazing. That's what you're trying to do. So you want it to end up looking like this. Okay. All right. So let's go back to this here. Fill this stuff in. So when you look at this, remember the lowercase r stands for the word reflect. The complex number z that's this, over the line L. That comes from that little symbol. So this says reflect the point Z over line L. And when you do it, it ends up, it's about here. So how do we accomplish that? Okay, that's what we're trying to figure out. Okay, so this is this point right here. This is the result of reflecting Z over the line L. Okay, so we want to take this point, let me turn this back on. Okay, we want to take this point and flip it over that line and find out where is it. Okay, all right, so this is what you're going to do. Take your tracing paper and trace the line of reflection and trace where Z is. Okay, so you're going to do that first. I'll give you a second, trace that out. Okay, so in order to accomplish this, what we're going to do first, it says rotate the line of reflection clockwise 45 degrees so that it coincides with the real axis. So watch. Rotate this 45 degrees so it coincides. Oh, we're breaking up to the real axis. Whoops, went too far there. Hold on. Try that again. Just like that. Okay? Yeah. Yeah, if you can stick around, you might want to see this. Okay, but we're getting some interference here. So did you see what I did? I just turned it. Okay, so we're going to take that drawing and copy it onto our second figure, like that. Okay, so I took this and I rotated it 45 degrees clockwise. Boy, that's really bad. Hold on. Okay, so I got Z2 by taking this line and rotating it 45 degrees clockwise. That's, look at, see how it says that right here? Oops. Z2. Sorry about all the pixelating, guys. All right. Now what we're going to do is do this next part. It says, now take the point and reflect it over the real axis. The new location of Z2 is called Z3. Transformation is accomplished as follows. Okay, so talk about what we did. In figure 1, to get figure 2, we rotated this 45 degrees clockwise and drew the new result, which was right here. Okay, so that's how you got Z2 right there. Okay, then we took Z2 and we flipped it over the real axis and we got Z3. So to flip something over the real axis, that's how you got Z3. That's this right here. All right, so our first step was we did this. We went R, do this in red. Okay, so this here was R, negative 45 degrees about the origin. So that was the same as rotating the opposite of theta. This is theta right here, 45 degrees. Question? All right. Then that put the point like right here. Okay, then what we did was we took that point and we reflected it over the real axis. Okay, yeah, you might want to, if you can, watch this first, but that's up to you. Okay, so here's what we did. So this thing was reflect over the real axis. Okay, so that put it down here, and we called that Z3. So when I rotated this, remember we drew a line right here. When that rotates, it ends up right here. When we flip, it doesn't move, it's still right there. That's still the line. Okay, then to get it back where we were, we're going to take this and we're going to rotate it counterclockwise 45 degrees. Okay, so now this is going to be rotate whatever theta was. And when you do that, this red line goes back to where it was, and your point lands right on 1 or 5 plus 1i. And there's my result. Okay. And we called that Z4. Okay, and this is the reflection of this original point over the line. So this point right here is written like this. Okay, so you got to understand what these notations mean. Okay, so I'm going to go through them one more time here. All right. So this first one says, take the original point Z, rotate it negative 45 degrees, and it turns into this point. Okay, so here it was. Take this in yellow, rotate it 45 degrees clockwise, and now it looks like this. Okay, then take that point and flip it over the real axis, and it becomes this point. Okay, now to get your final answer, take that point and rotate it positive 45 degrees. And it ends up right there. That's Z4. So this is the result. And I don't want this notation, guys, to confuse you. This is the reflection of the original point over the line L. This was line L. Questions on what we did there? We're just learning the geometry of it. Okay, now before we get into actually how you get the formula, let's say that you wanted to rotate something. If I asked you to do this, rotate, or no, I want you to write the equation that would give me this. Or how would I do this? I want you to reflect over the line L, and L is 60 degrees. I want you to take a point and reflect it over that line, but now it's 60 degrees. Okay, so all you got to do is go right through this step. Watch. First, rotate negative 60 degrees. Second, reflect over the x-axis, or reflect over the real axis. Third, rotate it positive 60 degrees. And that's how you would accomplish it. Okay, if I asked you to do this, reflect, so reflection is lowercase, and this was 135, a line that was 135 degrees. So I'm going to put line L, and this is what line L looks like. Actually, we'll do this. 135 degrees. How would you take a point and flip it over that line? So if you had a point here, how would you get it over here? Okay, so your angle is 135. So just do these 3 steps. Rotate negative 135. Reflect over the real axis. Rotate positive 135. And that's how you would accomplish those 3 things. You see the pattern there? Yeah? Questions on that? All right. Tell me how you would do this. Reflect it over the line L, but now the line L is negative 30 degrees. So what are you going to do first? Hold on just a second here. What are we going to do first? Yep, rotate positive 30. The opposite of the angle. If the angle's negative 30, you're rotating. Now what's the second step? Reflect. Third step. Rotate what? Negative 30. And that's how you would achieve that. By doing those 3 things, you'd end up reflecting it over this line right here. Okay. All right, now we got to get into how you put all this together. Okay, and we'll just start on this. We won't get through all of it, but you've got it. This is where you kind of end up with some crazy equations. All right, here we go. Okay, so we're going to put the whole enchilada now, put it all together and come up with an equation that gives us the result of reflecting it over the line y equals x. Okay, so start with this. The reflection over the line L of Z. Z is our original point. Okay, now our original point, guys, has the coordinates 1 plus 5i. That's where we started. Okay, all right. In our drawings up here, that was this value right here, Z4. So this is equal to Z4. Okay. All right. Well, how did we get Z4? Right here. So I'm going to take out the variable Z4, and I'm going to replace it with R 0, 45, Z3. Okay, so I just took out the letter Z4 and I put this in its place. Okay, I substitute it. Are you with me? Okay, now how do you get Z3? So take your equation. Okay, now I'm going to make a bracket because you get too many parentheses. What are you going to replace Z3 with? What's Z3 equal to? Well, I'm going to take out the letter Z3 and I'm going to put R, real axis, Z2. So all I'm doing, guys, is I'm just doing this substitution here. If I was going to color code this, I took Z4 and I replaced it with this. Then I took Z3, okay, I took this part and I replaced it with this. Okay, and now the last one, I'm going to take out the letter Z2. Oh, can't see it if I do that. I'm going to take out the letter Z2 and I'm going to replace it with this. Okay, so now this is going to be R 0, 45, bracket, real, whoops, reflection, real axis, and now instead of writing Z2, I'm going to write I'm going to write this. Okay, so that's going to be R negative 45 degrees about the origin, Z. And that's how you get the reflection over the line L. Now it looks kind of crazy. Okay, but to understand what you're looking at, and then we'll call it a day. Look, guys, remember when I told you, what do you do first? Rotate. Look, see how that says first? Rotate negative 45 degrees. That's this right here. Rotate negative theta. Then flip over or reflect over the x, the real axis. Reflect over real axis. So this was first, second, and now the last thing you do is rotate positive 45 degrees. See, it's those three steps. This is a composite function right here. And when you're evaluating a composite function, you start with the innermost function and you work your way out. Okay, this is the innermost function. You do that. This is the next function. You do that. And then this was the third function. You do that last. So if I was color coding this, these are my steps. Whoops. I mixed up my colors there. Darn it. Let's go. Undo. Undo. There we go. Okay, so this is supposed to be reflect. That's green. This should be green. Green, 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 green. This should be green right here. And then third was this. You're working your way from the inside out. All right, we'll stop there and we'll pick up with this.